Welcome to this class about the abstract factory design pattern. I will go through the theoretical aspect of the pattern, but we will also code the pattern together in C#. Let's get started. The intention. The intention is to offer an interface for creating sets of related or dependent objects without defining their specific concrete implementations. In simple terms, the abstract factory pattern lets you create groups of related items, like buttons, checkboxes, or windows, without having to worry about the specific details of how each item is made. It provides a general way to make these items, so you can easily switch between different types of items. For example, buttons for Windows or for Mac, without changing how you use them. The participants. Now we will have a look at what participants will be created during coding. What is their purpose and how do they interact? So we have the abstract factory, which defines an interface for processes that create abstract product objects. We have the concrete factory, which creates concrete objects by implementing the operations of the abstract factory. We have the abstract product, which declares an interface for a type of product object. We have the concrete product, which implements the interface of the abstract product. And we have the client, which uses only the interface to interact with the factory interfaces. The consequences. Implementing the abstract factory pattern has consequences to the system you are building. Let's evaluate these consequences. It isolates concrete classes. The abstract factory pattern is like a factory that makes different kinds of products, like buttons or windows, but you don't need to know exactly how these products are made. Instead of directly handling how each product is created, the factory takes care of it for you. The actual process of creating the product is hidden inside the factory. So the client just uses the word product without needing to know how anything is built. In short, the client isn't aware of the concrete classes. It makes exchanging product families easy. The concrete factory is like a hidden behind-the-scenes worker that only shows up once in the whole app, when it's called to create products. This makes it easy to switch to a different type of factory whenever you want, without changing much in the rest of the app. So if you change the factory, all the related products like buttons, checkboxes, etc. change at once, because they all come from the same factory. In short, changing the factory will change the products. It promotes consistency among products. When you have a set of products, again like buttons, checkboxes and windows, that are designed to work well together, it's important that your app only uses products from one set at a time. The abstract factory helps make sure that the app sticks to using products from the same set, so everything works smoothly together. Like these cans on the right side, they are all the same size, but the printing on them is different. In short, you enforce consistency among products with the abstract factory. Supporting new kinds of products is difficult. Adding new types of products to the abstract factory is tricky, because the factory is already set up to make a specific set of products. If you want to add something new, you have to update the factory and all the different versions of it, which can be a lot of work. This makes it harder to expand the factory without making big changes to the whole system. Let's say we have an abstract factory that enforces consistency in the manufacturing of cans. Then adding cameras as a product would require big changes to the system. In short, a new type of product requires big changes in the system. Now let's take a look at how one would model the abstract factory by using UML. We have the abstract factory, which has two empty functions for enforcing the creation of two different products. The abstract factory is inherited by two concrete factories, which create different products, A and B. Concrete factory A, for example, could manufacture Coca-Cola cans as product A and Coca-Cola bottles as product B, while concrete factory B could manufacture Pepsi cans as product A and Pepsi bottles as product B. As you can see, we have abstract products, abstract product A and abstract product B. These abstract products are inherited by concrete products. The create product functions in the concrete factories have as a return type the abstract product, but do in fact return the concrete version. Now we are going to start on the assignment. The objective of the assignment is to implement the abstract factory design pattern in a C# console application. You will create families of related or dependent objects, UI elements, and encapsulate their creation in concrete factories without exposing the client code to the specific classes. You can also find the assignment on my GitHub, which will be in the description. The first task is to define the abstract products. Create abstract product interfaces representing different types of products that your application will generate. The first requirement is to define an interface for iButton with a method render to simulate drawing the button. The second requirement is to define an interface for iTextbox with a method render, again to simulate drawing the textbox. The first task is rather simple. We create an interface iButton with the empty function render. And we do the same for iTextbox. And that's it. Task 2. Implement concrete products. Implement concrete product classes for two distinct UI platforms, such as Windows and Mac. The first requirement is to create concrete classes implementing the iTextbox interface for both Windows and Mac platforms. The second requirement is to create concrete classes implementing the iButton interface for both Windows and Mac platforms. The third requirement: each concrete class should provide a unique implementation of the render method to simulate the rendering of the specific UI component for its platform. Now we are going to implement the abstract products iButton and iTextbox into concrete classes. Let's start with a Mac button. So for Mac. Next up, one for Windows. It's basically the same process. Up next are the text boxes. and the last one for Windows. And that's it. On to the next task. The third task, define abstract factory. Create an abstract factory interface that declares methods for creating related products, the buttons and text boxes. The only requirement is define an interface IUI factory that declares methods for creating both buttons and text boxes. So the functions create button and create text box. The creation of the abstract factory is quite simple as well. It just has two functions. That's it. The fourth task, implement concrete factories. Implement concrete factory classes to create the respective UI components, the buttons and text boxes for each platform. The first requirement is to create concrete factory classes for Windows and Mac platforms that implement the IUI factory interface. The second requirement, the concrete factory method should return instances of the appropriate product classes, buttons and text boxes, for the specific platform, so Windows or Mac. Now we are going to implement the abstract factory into concrete factories. Let's start with the Mac factory. And it's going to return the concrete button. And here, the concrete text box. Like this. Let's do the same for Windows. Like this. And these are basically the factories. But what is common with the abstract factory pattern is that you want one instance of a factory. To enforce this, we can use the singleton pattern. I have a video about the singleton pattern if you want to learn more about it. But let me show you how to implement the singleton pattern into the factory. So first we will create the field instance, which is nullable. We will set the constructor to private, so developers can't create new instances of the factory. So let's make it private. As last, we will create a function called getInstance for retrieving an instance of the factory. What you see here is called lazy initialization. If instance is equal to null, a new instance of the factory is assigned to the field instance. If the field instance is not null, it is simply returned. Now let's do the same for the Mac factory. And that's it. The fifth task, create client code. Create the application basically. Write the client code that uses the abstract factory to create UI components without depending on the concrete classes. The first requirement is to create a class application that takes an IUI factory object in its constructor. The second requirement, implement a method in the application class to create and render a button and a text box using the provided factory. The third requirement, ensure that the application can switch between different factories, the Windows factory and the Mac factory, dynamically. Now we are going to create the application, which will take the abstract factory as a parameter in its constructor. We have to be able to switch between factories. So let's create a function for that. And we have to be able to render the components, the buttons and text boxes. Like this. This is the application. The sixth task is to implement the main method. Write a main method in a console application that demonstrates the use of the abstract factory method. The first requirement is, in the main method, instantiate different UI factories, so the Windows factory and the Mac factory. The second requirement, pass these factories to the application class to render the UI components for each platform. The third requirement, output the result to the console, showing which platform-specific UI components are being rendered. As last, we will test the application. As you can see, the different UI elements are rendered. I hope you learned a lot from this lesson. If you feel like you don't understand the pattern as much as you would like, then I suggest playing around with the code or rewatching parts of the video. See you in the next one.